welcome everyone. I see some people are still joining. We will start on schedule because the agenda is quite full. So my name is Paweł Turkowski. I work in CloudFerro as a product manager for our Kubernetes offering and also other IaaS solutions. So yeah, I will be happy to share some of my experiences with Kubernetes. I'm only part of the team that works on our solution, and there's many more people involved there. The agenda for today will be we'll first just briefly introduce ourselves. We'll talk quickly about containers and Kubernetes, just to get everyone on the same page. And then we will introduce the Kubernetes package management, which is quite fundamental in deploying applications quickly. And then we prepared a couple of sample deployments that are focused on Earth observation and science. So I hope this will be interesting for you. So the first part about the introduction. We as CloudFerro, we are a cloud company. So we deliver both public and private clouds. We are focusing mostly on Europe. So this is our key focus area where we have we're making sure to comply to all the European standards, and we work with institutions that often for them it is fundamental. We focus on large data sets. We store a lot of data. A large part of this data is Earth observation data, and these are large petabytes of basically storage. These are our data repositories for different clients. This is the EO data part, which is on the chart, and this is a bit of a history. We work with companies like European Space Agency or EUMETSAT, VACIO, DLR, some large institutions in charge of Earth observation and climate. Yeah, this is our key domain. Of course, the cloud is suitable for all different use cases, but there are some things that make us quite special in terms of access to Earth observation data. Okay, I want to move to the part about Kubernetes and containers, and there is a lot of audience, and the audience is also mixed, so there might be some more technical people and less technical ones. So I'll try to make it balance. Maybe before I dive into the deck, I want to just make a couple of remarks. So I'm sure there will be some questions. I'm the only presenter here, so the facilitation of the questions I will take at the end. I will start with this very basic explanation just to set the common ground as much as possible. We will then move to the live demo, and for the live demo, please excuse any technical problems. I'm sure there might be some, so we'll see how it goes. Please refer to the previous webinar, which we also organized, because we were maybe not so much focusing on the deployments, but about some other aspects. So I think these two webinars are kind of complementing each other. And then also for the demo, please excuse that not all of these applications are production grade, but they are a solid backbone to make them production grade. And then maybe just one remark to not use PowerPoint for code snippets, just copy to notebook because there are some copy pasting errors in PowerPoint. And maybe one last remark, in the live demo, we will be jumping between deploying applications and presenting already ready application, because it is just the way it will be feasible. Because the deployment on load balancers, it takes some time. Okay, moving to the overall Kubernetes. So many of you know this is a system to basically provision clusters. So Kubernetes itself is a system that runs a cluster of master nodes and worker nodes that are used for exposing and load balancing applications, automated scaling, rollouts and rollbacks of deployments. It basically is a platform for ensuring that the applications are well orchestrated. The official definitions is that Kubernetes is an open source system for automated deployment, scaling, and management of containerized applications. And I highlighted here these two things, that it is a system. So we'll just briefly explain what the system is about. And the foundation is the containerized application. So also I'll just give a quick recap. So how containers work. If I have my machine with Docker installed, I can build on Docker my application's image. I can push it to the container image library, and somebody else might just use this image without being particularly concerned about the operating system, because the operating system is also bound within the container. And then also I can use other images as a base to my own image. And then how does this work in terms of Kubernetes? And this is a really like a simplification. We have a Kubernetes cluster that operates on worker nodes and master nodes. Here for simplicity, we just have one master node, but they can also run in high availability. And then these are basically machines, are there either physical machines or virtual machines. And the way that I'm interacting with this Kubernetes cluster of machines is by sending either kubectl commands, or more often running the YAML manifest also via kubectl or other dedicated tools. And then I need to authenticate over a kubeconfig to be able to access the cluster. And we'll see quickly in action how this works soon. Maybe just a couple of words about the Kubernetes deployments. So the way that it works is that if we have these nodes, the worker nodes, then the applications are deployed, and then here you can see a pod is a unit of operation in Kubernetes. And then if there is, for example, more load, there are other copies of the same application exposed, so that for example, to answer to increased traffic, or they can also scale down depending on this traffic. And then it can be either applications or jobs, whatever software. And then an example of this Kubernetes deployment, a very basic one, is, and this YAML manifest, there is a deployment, and then there is a service for exposing this deployment. And here in the deployment, we specify how many replicas, so how many pods can there be. And then, of course, we can also auto-scale this deployment later on, which we more described in the previous webinar. Here maybe one important notion that we will be referring to through the demos is the notion of the namespaces. So a namespace is basically a separator for applications. It's a logical separator, but it's also a functional separator. So it can also serve for different access levels, granting different access levels to different resources and to different users. And then one thing that I would like to also say is that there is that we operate on this OpenStack Magnum. So this is integrated an internal part of OpenStack. So this is what we use as our base for our Kubernetes implementation. This basically allows anyone with the account on a currently WAF 3.1 cloud to just access the Horizon interface and create a cluster with a couple of steps. And so the creation process is a couple of fields. In the most simplistic form, it's probably 1 minute of clicking. And the key decision is to specify how many master nodes and how many worker nodes and which flavors you want to have. The process of the cluster creation, it takes basically several minutes. It's because it's created in the bottom, the virtual machines are being created, load balancers and so on. Okay, so this was a very brief introduction to the Kubernetes on our clouds. And now what I would like to discuss is a couple words about the Kubernetes package management. So in general, the way that Kubernetes works is we saw an example of the YAML file a few minutes ago, where there was a deployment and there was a service. So both deployment and the service are Kubernetes resources. And these are not the only ones. There are there is probably around 100 of resources which are standard and built to Kubernetes, but there is also custom resource definitions that can be added by different application developers who want their apps to be run on Kubernetes. In order to deploy these resources, usually there is quite some hefty writing of YAML files, and the package management is here to help with this. So one of the most prominent examples of package management in Kubernetes for Kubernetes is Helm, and this software basically enables to package really large and complex Kubernetes applications that consists of many resource definitions and the relations between these resources that are often very tricky, but Helm makes it possible to interact with it on a very high level and not really being an expert on the specific definitions. Of course, there is some part that it really helps and sometimes it's useful, but the base is very solid. So this is a great starting point. It's not the only one. You will see that other applications are also packaged in a different way, but the foundation is the same. It basically provides the resources in an automated fashion that can be then just adjusted and fine-tuned to the liking of the person that is deploying this. So in maybe more simple example, the way that that this works is that without Helm, let's say you need to write this. Here is a very small example, but normally it could go into hundreds of lines, and then you need to often repeat this boilerplate code, specifying the labels and the names of various parts of this resource so it is recognizable. And with Helm, these templates are provided, and then the only thing you need to modify is the specific values that you want to adjust. So here, let's say I want to change the image from Nginx to Apache. It's just a matter of exchanging it here. Of course, that might be an oversimplification, but it is really indeed very quick, which you will see how the foundation is very quick to set up. Okay, so here I'm adding a couple of steps to start using the Helm charts. I will not demonstrate it right away, but the key thing is to install Helm, and then you operate with the repos. So adding the repo, and then once the repo is installed, let's say Bitnami repo, then from this repo I can install a specific Helm chart, and we will see this in action just in a moment. Okay, so what I would like to go into, and this is the end of the theoretical part, is that we'll focus right now on the sample deployments. Yes, we could consider this actually even as a type of a complete, let's call it, solution, where when dealing with Earth observation, maybe there is a specific scenario where, first of all, okay, I want to experiment with some solution. So I'm using a JupyterHub, and we will deploy a complete base for the installation of the JupyterHub. Then I might, once I have my pattern on image processing, I want to apply this pipeline automatically for hundreds and thousands of images, and Argo Workflows is a great system for workflow management on Kubernetes, where each step of the workflow works as a container. And then the last step of the sequence might be, okay, once I already have my images, I want to serve them on interactive maps on a WMS, and we will show a specific implementation where we actually wrote our own Helm chart to deploy automatically a WMS with scaling capabilities and so on, which can be perhaps used by you if you wish. Keep in mind that for some of the EO examples, these are some simple examples. I have my colleagues in data science that know much more about the Earth observation aspects. Here I'm focusing a lot about Kubernetes, how it can be done. So the examples are just for illustration. Okay, so we'll start by deploying a JupyterHub. So I will share my screen. Okay, I hope everyone can see my screen now. So here I have my horizon, I have my clusters. I will operate on two clusters, Scratch and Scratch2. Yeah, just a quick reminder, you can create your clusters here. You could create another cluster from this user interface. I will not do this right now. I will right away go into Linux. And here I have my first cluster, Scratch, and I have my cluster Scratch2. So I will use the Scratch2. This is in order to demonstrate how to deploy the applications. And on Scratch, the applications are already deployed. So we will most likely most of the time present from the ready applications from this, just because the load balancer to expose it usually takes a couple of minutes. So before we can see the things in the browser, it will take some time. Okay. So in order to so JupyterHub, I hope everyone is familiar with it. It's basically a tool that enables to run some experiments just simply in a browser. So it's very convenient, and you can run different code there, Python, Julia, or other libraries. So in order to install JupyterHub, I will show you a quick couple of commands. So first of all, we'll create a namespace for this JupyterHub. This is a good practice to always have a dedicated namespace. Now, the thing that is maybe specific to the implementation on our cloud is that with Magnum there is some specific security constraints, and to overcome these constraints, we will apply a role binding that basically links service account that we use to run in our namespace JupyterHub. It will give the Magnum privileged rights, so it will enable JupyterHub to do its work without any complications. And this one, for this one and for also other deployments that we have here, there are instructions either on our website. So there's a very complete documentation of these things. So I'm okay. Yeah, there is some issue with copying and pasting. Sorry for that. So this is created right now, and now we can move to the actual step. So as I mentioned, we'll deploy it with Helm, and this is in fact like these two comments. We need to add the repo, and we need to install the chart, right? So this will be very quick. The repo I already have, so it will just say, okay, you already have this repo. Normally it would probably take a couple of seconds to download this repo. I might want to update this repo, which I'm showing the example on the PowerPoint, but here I have everything up to date. And it's Helm repo update, basically. That's what I would need to type there. I'll not do it. And now I can install the chart. And what is happening here, I'm installing a JupyterHub from the JupyterHub repo in some specific version into my namespace JupyterHub. Okay, so this is doing its job right now. Sometimes it takes a bit of time. We'll see. Maybe just wait a couple of minutes. Not minutes, but oh yeah. Yeah, so that's it. So JupyterHub is right now installed. And the only thing that I want to do right now, I have actually some. Sorry, I have something visible there that is not allowing me to. Okay. And then in this namespace, I want to see different services that are started. And one of them is this proxy public. It's exposed as the type of load balancer. And right now I'm waiting for the IP address. Okay, so let's see, maybe the service is already created here. Yes, so there is already the external IP available. So what we can do is we just type it into the browser. And here we have our JupyterHub deployed. So this is running with a dummy authenticator. So if I just put any credentials, it will work. Normally for production, you would like to implement some authentication, which is available on the JupyterHub Kubernetes deployment side. And now the things are starting up. Okay. Yes. Okay. So we see that it is available, and this is the instance from the perspective of this specific user. And now, yeah, I can just fire some Jupyter notebook and run. So this is working out of the box. You saw it was basically 2 commands plus this role binding, and we have it up and running. And of course, as I mentioned, it is not production ready yet, so you might want to implement HTTPS if this is your requirement, or you might need to implement, of course, the proper authentication. But the backbone is very quick to set. Okay, so I will switch back to the presentation. So this was our first deployment, and the steps are provided here. Please refer to the document. So I'm pretty sure actually that for JupyterHub also the HTTPS is available in our instruction. Yes. And yeah, that's basically it. So a couple of commands, and we have JupyterHub available. So now let's try to do the same type of thing with Argo Workflows. We want to deploy Argo, which is it will enable us. Oh, sorry, I'm skipping through the wrong place. Yes. So it is similar with the Argo workflow. So this is a tooling to manage this complex workflows. Maybe the sequence is not the best. I'll first show you the steps to install, and I'll apply it immediately. But in a moment, I'll show you also the logic of the workflow. So similar as in JupyterHub, we create a namespace, we apply this role binding to overcome some security constraints. We run the installation. This is one is not with Helm, but with just a custom. It's a custom YAML file that deploys various resources. We will patch this deployment for this demo purposes because it also requires authentication, but here we need to just put this construct here to change the authentication mode to server. So we might want to change it for production, and then we should get this. One thing that we will also change is we will change it to the type of load balancer so that it is exposed publicly on the internet. Okay, so first we will create a namespace Argo. Then we apply the role binding we mentioned earlier for the JupyterHub. It's slightly different, but it just binds another namespace, so the Argo namespace. Actually, I have it already there, so yeah, it's unchanged. And then we'll patch this deployment. Sorry, we'll first, of course, hide the deployment. And you can see there are the custom resource definitions deployed by Argo. And now we'll patch this deployment. It is basically to change the authentication mode to server, so it's also to surpass the authentication, similarly as in JupyterHub. I'll clear my screen. And then another steps that needs to happen is there is an executor role that is basically to also get rid of some privileges. It's for a different reason than the previous role binding, but here you can see the executor role. It's a tiny thing that needs to be changed so that this workflow task results can be deployed. That's linked to the volume creation. So let's apply this role. Then also let's apply the role binding. Okay, and then one last thing that we'll do is we'll patch this service to be a load balancer type. Okay, and that's basically it. So now we should have it deployed. It's deployed. Sorry, the namespace Argo. External IP is pending, so the load balancer was not created yet. We'll then reach out to this other cluster. And here I have the IP available. So I can go to the browser, type this in, but here is a bit of a change versus the JupyterHub. So it needs to be on HTTPS and it's served on port 2746. That's the default that you can also change. So actually there is some workflow already there. I will just delete it for clarity. And now I will show you the workflows that I've prepared for you, some samples. So here you can see the sample workflows. So this is the GitHub repository that was prepared for this demo. The first workflow is the one that we have in our documentation. It's a very basic one. The empty dir is, let's say, something in the middle, but I would rather recommend to go straight to the EO workflow volumes. This is more straightforward and more scalable It's a bit more complex than the previous one, but not much more complex, but it's much more complete. So it uses the persistent volumes to transfer the files between one container, so the downloader, and then the processor. So yes. So this is the workflow that we will run, the sample workflow. So we will basically have something that is designed as an ARIA selector. It takes input from in form of list of different areas to process. We'll take, for example, Italy and Denmark, and then it splits into steps, and then for each step there is a volume generator. It will create a persistent volume claim. So persistent volume claim is basically acting in a form that it will create an actual block storage in the cloud, and this block storage will be used only for this volume will be only used for as long as the workflow runs. So this is this beauty of Kubernetes, where it actually only takes the resources when it needs them. You don't need to pre-provision a volume that will be there forever. You'll just use it for as long as the workflow runs. And then we have a downloader step that pulls the images from the EO data based on this input, for which area to take the images, and then it will process these images. Okay, so I will share my screen right now. Okay. So I have this workflow here. One more thing that I need to mention is that on this cluster, there is also an executor role that I implemented, and the instruction I will show you in a moment. It is another permission that needs to be granted because we are creating a volume, and this will need to be taken care of. So we are adding an executor role, but this is basically what mirrors the picture that I showed before. Is that we have a region selector, and here we can have a quick look also that there is a region selector that takes this hard-coded for now input of Denmark and Italy, and you could change it here or refer to some place where it should be taken from, and then it moves to the step of the volume generator, which will create these persistent volumes. And here we can see it basically, these workflows, they operate with the steps and then also with the step templates. So it is creating here a persistent volume claim. Read-write once is what we support. It is hard-coded 12 gigabytes of storage. And here also we can have a look. Oh, sorry, not the right place, but I will anyways jump here. So the final step of this workflow is that the images, once they are processed, they will be sent to my S3 bucket. So at the end, we should see them here. It will take around 10 minutes, this workflow to run. So yeah, we will probably see it a bit later. And then you can see the volume of this 12 gigabytes is also being created here by the workflow. So this is this way how it flexibly can handle such scenarios. Okay, we will move now to another already another deployment, and then we'll get back to Argo just maybe to quickly check if this step has finished. So the last deployment that we have is the WMS server, and this is something that we developed as our own invention. It's a custom Helm chart that you can download from GitHub, and you can deploy MapServer on Kubernetes. It deploys MapServer instances as pods, and then yeah, it's based on S3, so that the workflow is the following. Operator does not need to really have a knowledge of Kubernetes. They can operate in a way that they upload their map files. And then there is a cron job, which is also a resource on Kubernetes that refreshes the contents of the S3 bucket on a schedule. And then the folder etc map server in the container detects these changes and is updated. So every new map file then gets served by map server. And then in the map files, you can specify in the configuration section the source. So we will use here for this example just one bucket, but in general, you probably want to have two different buckets, one for map files and one for EO images. So this could, this could be basically separated. I will switch to my screen. Okay, so I hope my screen is visible. And this is the repo. Okay, so this is the repository. It's quite okay documented, so you can see which steps are needed. So you add the repository, then you need to create this customization file, which is what I was explaining earlier. This is the file where all these different configurations are being made, and at minimal, you would need to provide the keys, the S3 keys to your S3 bucket, where you will be uploading the map files. Then you install the chart, and that should be it. So I will right now perform these steps. So actually this is redundant because I already have this, so I will not even do this because the repo is added. The repo is on my local computer, so it's okay. But then the next step is to install the map server with the my values TM. I will just quickly maybe show you the so here you see I'm changing the coordinates, and I'll need to change my keys, but these are the keys to my bucket, and then the cron job schedule. You can also modify a couple of other things. So I'm using this my values file with this configuration override. And note that a lot of these things you don't need to type there because the defaults will be taken. The only thing you need to really add for sure is your keys. And yeah, maybe the schedule, but the schedule is also there. Okay, so that's already deployed right now. And again, we have a situation where we wait for the service to pop up. So I will rather look it on the other cluster. Deploy to the CF MapServer namespace. So it is running here. And if I type it to the browser, I will not see much because it will just be a query not available. But then I can type this most basic command of get capabilities in MapServer. That shows that this is running, and I'll also paste one more command. But before I do so, I want to show you from where it is being taken. So here, as I mentioned, I have just one bucket. So I'm storing my map file and I'm storing my image in the same bucket. So right now I want to serve this image using this map file. So I can verify that with this very complex query that very honestly my colleagues from data science know, but it's rather they take it from some geo software. But this is a query basically to get the coordinates of this image. And then here we have a Cyprus image, and it is available. It is being served by MapServer. So this is great. But now what we can also do is we can see it as if it would be served by some simple web application, let's say, so some front end, and it is here. So this image is served as a leaflet app, but yeah, normally you would scroll. Okay, but I will not focus on this here. Okay, that would be the part about this. Maybe we get back or not. Let's do one more thing. What I want to just say for this Helm chart of the MapServer, I'll switch to the PowerPoint for now. So here we also have the comments, what needs to be done. And then for some customization about this MapServer, this basically runs based on simply copying from S3 everything that has a map extension and just taking it to MapServer. You could exchange this init image. So this init image is what is taking. It's a basic Python script that does that. But you could exchange this init image to any script that could be maybe doing some manipulation of this map files or maybe even creating them. So it is quite flexible from this regard. Okay, and yeah, just a very last look on the MapServer. So here you have, if you want to play with it, there are these samples with the Cyprus and so on with the sample requests, and that's basically it. Let's just quickly go back to the let's just quickly go back to Argo. So Argo also finished. The process has finished, and I probably didn't say it before, but there was a basic processing going on there that was doing RGB processing, and we can see that the images were downloaded for both Denmark and Italy, and these images are available also for you in this Argo repository. The scripts for both the downloader and for the processor are also available. Of course, you might want to customize them to your liking because the operations here are super simple. I'm sure there are on the audience people that know much more about some complex manipulation of these files. Okay, I will then conclude because we are reaching the end of this webinar. So I would like to maybe make you aware of the fact that we're producing quite a lot of documentation on Kubernetes, and we are especially focusing on the integrations because that gives the power. There is a lot of people and companies that want to make their applications available on Kubernetes, and we saw a couple of examples today, but there is much more that can be used. So yeah, please also give us any feedback if you have some, or if you're using some specific integrations that you believe would be interesting for us to have a look at. That's it from our side. Thank you very much for the event and for your participation. Goodbye.